So I just want to go through a few examples of matrices being applied to some different problems, and so you'll see how addition, subtraction, multiplication, division, and so uh, of matrices can be applied to the business areas, just for you to get an idea. Um, so let me make this a little bigger. Maybe y'all can see there.
Yes, sir.
I think when I'm recording, I'll capture all of the stuff around too, no? I wanted to capture not everything, but just this screen. All right. It's not so bad if we capture nothing up here that is private. Yeah. So here we have a situation talking about rice production of two different cities for the last 10 years. Okay, yeah. And that's what you see here, right? So this is like city A, city B. This is the rice production. This is the wheat production, right? And of course, and you see numbers like 50 and 40, and so it probably could very well mean maybe millions of tons, right? Or hundreds of thousands of tons. It could be all of that, right? Usually you don't put in all those zeros into a matrix, right? You want to use just the main figures that can give you an idea. And let's say you're dealing with 50,000 tons, 40,000 tons. You know that the 50 means times 1,000, The 40 means 40 by 1,000. Right? So keep that in mind. You're writing a matrix, don't put all the numbers inside. But so this is like a whole 10 years. But they're telling you that the forced year production for city A and B for rice and sugar. Sorry, I say rice and sugar. Rice and wheat are these figures. So if you're asked to find the rice production for the last 9 years, simple arithmetic. You subtract this matrix from this matrix. And that's what they give you, right? And well, you have to take out what they ask you for, right? Find the rice production for the last year. So it's this 45 and the 26, right? So city A, right, produce 45, city B produce 26. That wasn't so hard, was it?
No, sir.
Very simple, right? I'm recording it so you can always see it back later on. I have a recording of this already this morning. So look at another one. What's this? So they're talking about the cost of cultivation of three crops: sugarcane, cotton, and onion, right? And the costs are 40, 20, and 30,000 rupees, right? So they call three names here, three farmers. Kamaji, Ramaji, and Balaji. I think the writer is being funny, right? It's an Indian writer. So he just used three names. I think his name is Ramaji, the writer of the article. You notice these examples come from the International Journal of Management, Technology, and Engineering, right? So people hardly write about these things, and these simple things people write and publish. You believe that? I was shocked by the simplicity of this article, and yet this guy published it, you know? Yeah. So, okay. So here's this information about cost of cultivating sugarcane, cotton, and onion. And they want us to, well, okay, these three farmers, they cultivate a certain acreage on the sugarcane, cotton, and onion, you know? And they want to know, find the sum of money that they spend individually. You can get a total amount if you want to, but the individual amount of money they spend in cultivating these crops over those respective acreage that was mentioned here, right? I'm not reading the whole thing, you're watching it too, right? Read it. So you notice all this information when you read it can be very confusing. But if we are to put all of this on a matrix, it will look so nice, right? Nice and simple. So let's do that. So here it is, right? I didn't quite like the lettering here. I would have gone with, if this is sugarcane. How was it? Sugarcane or sugarcane, cotton, and onion, right? So maybe you should have used cotton here, cotton and onion here, right? And you need three names: Ram, Aji, what are the three names? Ramaji, Kamaji, sorry, that's Kamaji, Ramaji, and Balaji, right? So that's the acreage of the three guys, right? So Kamaji, he planted 10 acres of sugarcane, 2 acres of cotton, 1 acre of onion. I'll skip the middle one. Balaji planted 1 acre of sugarcane, 1 acre of cotton, 1 acre of onion, you know? Good. And these are the costs. The cost per acre for planting these things, right? So cost, right? As a cost, what do you call it? The cost matrix, right? So this is for sugarcane, that's for cotton, this is for onion. So to get the total cost for these various acreage that is planted with the various crops, you'll have to multiply this matrix by this one, right? And that's something you must know. What to put in front, what to put behind, right? That's a question you must answer for yourself. And remember, there is a condition. The first matrix is a 3 by 3. The second one is a 3 by 1. And because these two numbers are the same, if you are paying attention, by the way, I should ask the question if you all watched the video that I put out there on application of matrices. Anybody watching my videos? Anybody in the class? Did you all see me put out a video there on application of matrices?
Yes, sir.
Have you watched it? Everybody watched it?
Sir, I watched piece of it.
Oh my God, please. I sure you watched 2 Cody pictures this week.
No, sir.
Watched 2 movies this week. But you didn't watch my video. All right. Next week, Saturday, you will hear a story. You all watch the videos, watch it, maybe repeatedly, pause it, ask the question, what is guy talking about here? And try to make sense of it. You see, when you watch a video, that is the thing. You all would get questions to me today. But you all didn't watch the thing, so you have no questions to me. You probably just listen to what I say. So I was explaining that for 2 matrices to be multiplied, the number of columns in the first must equal to the number of rows in the second. And your answer is going to be the number of rows in the first by the number of columns in the second at 3 by 1. And that is what is going to happen here. Right? So when I multiply this by this, you get, well, you all know to do multiplication too, right? Rows by columns. 10 by 40, 400. 2 by 20, 40. 1 by 30, 30. And you add all of them up, and you get 470. Then this row by the column, you get these numbers, add them up. Then this row by this column, you get this last row, right? Add all up and you get 470, 320, and 90, right? Follow that example.
Yes, sir.
Yeah. And of course, now they summarize the thing here, right? Well, they converted it to millions of rupees, right? But you don't have to. You almost know these conditions and so, because I might have it's not all the questions might be, very long and involved. I can ask you little questions, Hey, yeah, to talk about watching the videos, y'all subscribe to my channel there. How many of you are subscribed to that channel that I have? Anybody? Again, but y'all really do, y'all watch my video free and don't even subscribe, man. Tough, tough. People gonna glad for 1 mark extra. All right. All right. Fight up. Well, look at this other one. So this is some production process, And they're making 3 different alloys. Alloy A, alloy B, alloy C. Right? Well, don't forget, right, that the examples we got to jump around all over. You see a lot of we had some farming example. And so we got to jump around all over because, well, there are all kinds of businesses there. Good. So we got 3 alloys being made, and the alloys are made from iron ore, chromium, and nickel mixed together. Right? Usually iron by itself is virtually useless. Yeah? A couple of weeks it can become powder again. So you usually have to add in some other metals to modify its properties, to give it strength, to give it resistance to corrosion, and so on. We are not interested in all of that. And I'm just telling you that for the sake of interest. Good. So in alloy A, this is how you have to mix the different components, right? 70% iron ore, 15% chromium, 3% nickel, and so on. Same thing with alloy B. These are the proportions. In alloy C, these are the proportions, right? They're asking you to find the requirement of each material for the production of 100 tons of alloy A, 200 tons of alloy B, and 50 tons of alloy C, right? So you want the requirement of each material, right? I'm talking here about iron, chromium, nickel. Good. So notice they formulated the matrix here. Let's pull up a little. Right? So they put, okay, this is what this is iron. The symbol that is used for iron is Fe. Chromium, I think is it a CR? Let me see it. And let me use an I for nickel, right? Good. And the proportions in each alloy A, these are the proportions, alloy B, and then alloy C, right? That's a proportion. Now I'll tell you something. And I was trying to explain this in a previous class. You might want to know, well, why didn't the person, the writer here, rearrange the matrix where they put iron, chromium, and nickel here, and put alloy A, B, and C there, right? Now remember what the question is asking. It's saying, right? It's saying you want the requirement of each material, the individual material. So when you multiply here by the 100, this matrix here, it will actually tell you, because rows by columns, it will tell you how much iron, because what? If you multiply this row, which is the various amounts of alloys of type A, B, and C that you want, by all the iron quantities, that will give you this, right? And therefore, this is the right format, the right arrangement of the matrix. If I were to have the matrix differently, where alloy A, B, and C is up here, when you multiply this by that, it's not going to work. It's not going to actually tell you how much iron you need, how much chromium you need, and how much nickel you need. Think about it, right? Then you go back to revisit this. It's not going to tell you that. But this arrangement of the matrix and the naming of the columns and rows will give you what they're asking you for. That's important. Right? That's important. You have to know how to arrange it. Right? Because if you were to arrange it differently, as I said, all right, let me do it here. I don't think you know what I'm talking. Let's say you put it like this: 70, 15, 3, 65, 10, 5, 60, 12, 4, right? So here, what you're doing here, this is alloy A, B, and C. And this is iron, quantities of iron that you need for each alloy, chromium, and nickel. And if I were to multiply that by this matrix here, if I were to put it here, 100, 250, right? And I multiply this matrix by each of these columns and put the answer here, right? What would happen is you are actually going to get, well, as a matter of fact, I'm not sure that the answer is meaningful, right? It's not even meaningful, because you are multiplying by how much tons of each alloy you need by, well, alloy A, the individual amounts of iron, chromium, and nickel that you need. And that wouldn't give you the information that they ask you for, right? So this arrangement is wrong. It's not going to give you how much of each material you need for the production of the 100 tons of alloy A, 200 tons of alloy B, and 50 tons of alloy C. No, it's not going to give you. So that's important, how to formulate the matrix. I keep that in mind. Good. So when you finish multiplying, notice you get 23,000 for the 145. Now, notice they mention here that you are making 100 tons of alloy A, 200 tons of alloy B, and 50 tons of alloy C. So that's only about what? 350 tons, right? You see, 350 tons of alloys, you know. Well, how come they got these big number here, 23,000, 4,100, 1,500? Really and truly, we did not use, when you say 70%, we should have put 0.7. When we talk about 15%, we should have put 0.15, right? But we didn't, because this particular writer, he's not comfortable working with these decimals, right? So he left the thing as whole numbers. So you got to remember that this 23,000, you got to kind of divide it by 100, and that's why you have 230 tons, right? Or what is that? Iron ore you will need. 41 tons, you notice he strike off the 2 zeros? 41 tons of chromium you need. And I think this piece is clicked out somehow. And 15 tons of nickel will be needed to produce, because that will add up. If you add up what? 230 plus 41 plus 15, you will get 350. Is that right? Is it 350? 350. I'm seeing something wrong here. 100 tons. Another 200, right? 350. These don't add up to 350. 230. 41. And 15 will give us only 250. So we gotta get 350. Or is it that you're losing? Can somebody help me with this calculation? 100 times 70 plus 200 by 65 plus 50 by 60. Can somebody help me with that? I don't have my phone with me. Do you get 23,000?
Yes, sir.
What do you get? 100 by 70 plus 200 by 65 plus 50 by 60. Just tell me how much you get.
Sir, 23,000.
Oh, you get 23,000. Okay. I wonder if one of these numbers are wrong, because they're not adding up. I thought it's supposed to add up to 350, because what, this is 100 tons, 200 tons like that, 50 tons like that. Isn't that 350? I'm stumped myself. Because this is 230 plus 41 plus the 15 gives me 250. Something is missing somewhere. But somebody do the 200 by the 15, 10, and 12 and tell me what you get. Oh, watch where the mistake is. You know, since morning and nobody didn't pick this up. Since Tuesday. The second one is 65% of iron. And you only got 50. You got 65. No, you got 65. 10. Oh, yeah, that's correct. 60. 10, 15, 12, 3, 5, and 4. It's supposed to add up to 250, 350 and not 250. Something not right. 240. Something is odd there, though. And I can't seem to put my finger on it. All right, you gotta take. Anybody try the force matrix by the second column and see if it's 4100? 100 by 15 plus 200 by 10
Yes, sir. It's 4100.
It's 4100, okay. And then the last row is 1500.
Yes, sir. The 1500.
You got 1500. So you strike out the two zeros again. You get it 340, you get it 41, and you get it 15. All right, you know what is happening here? Okay. It looks like there are other ingredients, right? Um, let me see something. Yes, yes. Look at what happens here. What's something? You notice that 70 plus 15 plus 3 is not 100%? Do you notice that one? 65 plus 10 plus 5 is not 100%. So there are other ingredients that are not mentioned here. Y'all notice that? So even though we need to make 350 tons of material of alloy, this weight that we're talking about here only adds up to 250. It means that that 100 tons, well, there are other ingredients, maybe, I don't know what they're going to put in there. Yes, now I'm seeing that. I didn't notice that this morning. You know, and those are things I might ask. Huh? Even I didn't see it. Huh? You all see what I'm talking about? In alloy A, these three ingredients do not add up to 100%. Because this is 70, 70 and 15 are how much? 85 and 3, 88. So 12% is something else, right? Maybe it's carbon. Usually they put in a little bit of carbon in steel and so, or whatever other ingredient, but they didn't name it. You see? They just didn't name it. That's interesting. That's interesting. Yeah. Okay. Hmm. Good. All right, let's take another one. Good. So here we have, all right, some companies making furniture. And the furniture is going to use a little bit of brass, a little bit of copper, a little bit of aluminum, and so, right? And there are three types of furniture, A, B, and C. Good. So here it is. You want to determine the number of pieces of furniture of each type that you can manufacture with 6.5 kilograms, 14.5 kilograms, and 8 kilograms of the three metals, aluminum, brass, and copper. Right? Are you following? You think closely? Right. So you have three types of material. You're producing three types of furniture. And in each of the furniture, right? Like the furniture A has this amount of aluminum inside, this amount of brass, this amount of copper, and so on. So how do you determine the number of pieces of furniture of the various types that you can manufacture with this amount of raw material in terms of aluminum, brass, and copper? Ordinarily, sometimes manufacturers do no calculation, right? And they might end up not optimizing their production. But with this method, we can actually optimize the production, right? So what's happening? So we're going to make we're going to say that, okay, let X be the amount of furniture type A that will be produced. Let Y be furniture type B, the number of furniture type B, and Z be the number of furniture type C that will be produced, right? So we make up these simultaneous equations, notice, right? So we're dealing with aluminum first, right? 0.5 kilograms of aluminum by the number of type A, then another 0.5 by type B, and then Z. Notice there's one here, right? So that's where you get a Z there. And all the aluminum used must add up to be 6.5 because that's what's available. And you form equations with the other material, right? The other material, brass and copper. You get these three equations, right? So you can now you don't have to use matrices to solve a problem like this. You could solve this problem without matrices. However, it lends itself to a matrix solution. And this is what we do here. We formulate the matrix, and really and truly, we want to find X, Y, and Z. So you can think of this matrix equation as this. AX equal B. We want X. So X then is equals to A inverse B. Right? A inverse B. So we need to find A inverse. That's the inverse of this here. Right? Now, in this particular paper, the guy didn't use the inverse. He used something called row operation. But we're not going to do that, right? We're not going to do that. We're going to find the inverse. Now, for me, I will not go find the inverse of this ugly matrix by hand. Instead, I'm going to use, right? So remember, we have to find X, Y, Z. It's going to be equal to the inverse of, all right, 0.5, 0.5, 1, 1.5, 2, 1.5, 1, 0.5, times 6.5, 14.5, 8. I need to find the inverse, right? Inverse. Notice I'm putting the inverse here. Inverse of this matrix, not the matrix itself. Inverse, A inverse. Notice I have a minus one. So what I'm going to do, I'm going to use a matrix calculator because especially dealing with decimals, you're going to have some very horrible figures, right? So I'm going to switch. I'm just going to stop sharing and switch to the matrix calculator online. And my advice to you, find a good one before now and next week. And know how to use it. Give me 1 second. Let me find my matrix calculator. Good. So here is my matrix calculator. And you will notice that the matrix that I, can you see here? Let me just see if I can annotate on the, okay. This is the matrix, right? That's the matrix we want to find the inverse of. You notice that? And the matrix calculator already did it for me. You see that? Y'all give me some feedback from y'all see it?
Yes, sir.
Good, that's the inverse. So I'm going to take this matrix and insert it up here. Click there. Oh, I need to stop. Good. I'm going to insert it on top here. So you see the matrix gone up there? I wanted it to be in a decimal form. Okay, maybe, yeah, they put it in fraction form, right? All right, well, in that case, if you're going to do that, I don't need to do it. Watch it. And I can now insert, you see this matrix here I have to multiply by? I can insert it there, there, and there. And click A multiplied by B. See that? And they will give me the answer as you see here. You see it here? So I multiply the inverse by the numbers, remember? The total amount of material in terms of aluminum, brass, and copper. That's what is available. So when I multiply this inverse by that, I get 2, 3, and 4. 2, 3, 4. That should be hard to do. Therefore, I can make two pieces of type A furniture, 3 pieces of type B furniture, and 4 pieces of type C furniture. Right? So you see our matrix calculator will help you. Make sure you find one. Make sure you know how to use it. Right? Good. So I want to stop here and go back to the problem. One second. Good. And when you, well, you know what the real method of solving it, right? Um, so you see the answer there? Watch here. Right? X is 2, Y is 3, Z is 4. So this means that you can make 2 pieces of furniture type A, 3 pieces of furniture type B, and 4 pieces of furniture type C. Right? From the metals that are available. Follow that one? Huh? No feedback, man. No feedback. All right, let's do a last one before our time catches up on us. Let's do a last one. Give me 1 second. I mean, 5 minutes. All right. And I need a whiteboard to. Oh, give me a second. Give me a second.